All right, so let's start out with some bell work problems. And these problems come from the last journal lesson. And I want to practice this skill with you guys. But basically, what we learned last time is if you take a root and you have an exponent inside and a root power outside, what you have to do to simplify is you take the exponent that's inside, so exponent here is m, and you have to divide it with the root. So then that will tell you what your new exponent is. So I'm going to grab a, which is my base, and I'm going to take m and divide it with n, and that will tell me my new exponent after you take the root. So let's demonstrate that here in our problems that we have. So starting with a here, this one here is just your typical square root, and we learned last time when you have a square root, there's actually a 2 that sits outside. You don't see it, but by default it is a 2. And so in this case, if I take the square root of the number inside, this is the square root of 16. Now some people can do this in their head. Square root of 16 is 4. Or you can do this in the calculator, but one way you can also do is this guess and check. Two numbers that multiply to give you 16 is 4 and 4. And since you have two numbers here that are the same, that has to be the square root of 16. And then looking at this here, you have a parentheses. So when you have parentheses, you're going to copy and paste that over and just take care of the exponent. So I'm going to grab the x plus 2. And then my exponent here is a 10. So I'm going to take the 10 divided by 2 to get 5. And then this here is my simplified root. Notice here I don't have the square root visible anymore because I've taken the square root. With this one here, I also have another square root. So again, there's a 2 that's outside this root. But I also want to mention here, we're going to have to take the square root of 36. And this is a negative 36. So first off, the square root of 36 is 6. But because this is a negative, this is not possible for us to take the square root because last time we talked about this, anytime you have an even root, you cannot take the square root or the even root of a negative number that's inside. So if that's the case, then this answer here is going to give us an imaginary number, and that would lead to no real solutions. So in this case, this one can't be worked out because this is an even root, and there's a negative inside, which would give us imaginary numbers, which leads to no real solution. So I'm going to skip over that one, not work it out. And then this one here, this is a cube root, and there is a negative inside, but we said if you have an odd root, in other words, 3 is an odd number. So if you have an odd root, this is okay. You can have negative numbers inside. And the reason why is because if you just break down 8, right? 8 breaks down to 4, then 2. Let me write this clear. 4, then 2, and then 2 times 2 gives you 8. So looking at this here, 2 times 2 times 2 gives you 8. But to get a negative 8, all I have to do is make them all a negative sign. So if they were all negative 2's, then if I multiply that all together, I'll get negative 8. And if you don't believe me, try it out. So the cube root of negative 8 is actually negative 2. And this is a, well, that's to the 9th power. So I'm going to divide that by 3 to get a to the 3rd power. And then b here, that's 18. If I divide it by 3, I get 6. So this here is my final answer, and I have simplified this root. So again, this formula here is very important to know. Anytime you're taking a root, you're taking the exponent and dividing it by the root. All right, let's get into today's lesson, which is about graphing roots. So before I can show you what the graph looks like, we need to start with a table. So I'm going to start by just graphing the square root function and seeing how that looks like. And when you start off not knowing what a graph looks like, you have to start with a table. Now I'm going to pick some x values here, and I'm going to choose some x values that are easy to take the square root of. You can choose any x value. I'm going to choose -4, 0, negative, actually let's do some positive numbers, 1 and 4, and then I'll figure out the y value. So all I'm doing is I'm choosing some x values so I can plug it into my function, get some y values so I can get some coordinates. And coordinates are just points that I can plot and then connect the dots to make a curve to see what the picture looks like. So this here's a negative 4, I plug it into the root, that's square root of negative 4. But we just said a moment ago, if you have an even root like a square root, you just get imaginary numbers, right? So this is going to leave me imaginary numbers, which here's the thing. When you have an imaginary number, you're not going to see it on the graph, right? Imaginary don't show up on the coordinate system. So there's no point in me plotting negative 4 for x because it's not going to even be visible. If I try negative 1 under a root is still going to lead to an imaginary number because that's a negative under a root. But if I do the square root of 0, this is perfectly fine. The square root of 0 is 0, and that's a real number. Square root of 1 is 1, and square root of 4 is 2. So in this case here, if I were to truly graph this here, let me make a coordinate system. This would be at negative 4 for x. I'm going to scale my x values first. 0 and then 4. All right, so like I said before, when we're going to go to negative 4 here for x, it's an imaginary number, so I'm not going to plot anything here. And then at negative 1, it's an imaginary number, so I'm not going to plot anything. So our first coordinate is actually 0, 0, which is the origin, so I'm going to plot it at the origin. And then my next x value is positive 1, so I'm going to go to positive 1 for y, so 1, 1 is right here. I'm going to plot. And then I have 4, 2, which is right about there. And then if I connect the dots, let me make those all green. If I connect the dots, it kind of curves. So a square root has this curve-like shape, okay? It always curves out. It's not a straight line. It's a curvy line. And you can see this really grow if you add more positive x values. Now keep in mind, notice how when I plugged in negative values, this wouldn't work for a square root, which is why you don't see anything here on the left side of the x-axis. So again, square roots are a one-sided curve, and it curves out. And this vertex here is actually right here at the origin. So this is the vertex. It's where the graph or the curve starts. So in this case, this is 0, 0. The y-intercept here, you can see across the y-axis at 0, 0 as well. And the domain talks about x values. So we learned a long time ago that domain is x's, and the x value that it starts at is right here. So x equals 0 is where it starts at, and then it keeps on going. So it starts at 0, it is heading towards the right side with an arrow, so it's heading towards positive infinity. So I put a positive infinity there, and we always use a parentheses for infinity. Notice how that is a closed circle at 0, so I always use a bracket for the number here for 0. As for range, it looks like the lowest y value here, because range is related to y's, the lowest y value here is at this point right here, and the y value is 0, so the lowest y value is 0. The highest y value, if you look at this curve, it does shoot upwards. This curve does go up, so it's going to positive infinity. So it's going from 0 to positive infinity. So again, square roots, you have a curve that's one-sided. It either can curve up or down, but it's only a one-sided curve. I like to think of this kind of like as like a surf wave or a trajectory, like something sprouting out. For cubic functions, let's investigate what that would look like. So I'm going to make some x values here. Maybe I'll do -8. That might be easy to use. -1, 0 is always easy. 1, +1, and +8. So if I were to stick in -8 into a cubic function, remember back in the bell work, I said that if you have an odd root, right, and you have a negative number inside, this is okay. So the cube root of -8, we kind of saw this in the bell work, it's -2. The cube root of -1 is negative 1. Think about it. Negative 1 times negative 1 times negative 1. When you multiply it 3 times, it's still negative 1. The cube root of 0 is 0. The cube root of 1, positive 1, is 1. And the cube root of positive 8 is positive 2. So again, these are coordinates that I'm going to plot. So I'm going to just do a rough sketch of this coordinate system. And I have negative 8 going to negative 1, 0, positive 1, and then positive 8. So looking at this here, I'm going to start at negative 8, negative 2. So here's negative 8. I have to go down 2 and then plot. And then I have to go to negative 1, which is right here. Then it looks like my next point is 0, 0, so that's the origin. And then my next point is 1, positive 1, so right here. And last point here is 8, 2, which would be right about here. So I'm going to curve the equation, and this side, notice how it curves upwards, whereas this side curves, kind of dips down. So this dips down. So when it comes to, actually, you know what, let me do that nicer because I don't think I curved that really well. So this curves kind of upwards, and this one curves downward. So it looks kind of like a zigzag, where it's almost like an S shape, but kind of more stretched out. So this here has a zigzag shape for a cube root, and it's because one side, when it's positive, it's going to grow positively or grow upwards, whereas on the negative sides, it's going to become more negative, so it's going to grow downwards. So with a cubic function, you're always going to get kind of like an opposite curve. One's going to go up, the other's going to go down. Now the vertex here is at the middle entry here. So that's my vertex at the origin. My y-intercept, again, is at 0, 0. As you can see, this crosses the y-axis at 0. Now, domain. Domain talks about the x values, and this does stretch left, and it does stretch right with arrows. So it's going from negative infinity to positive infinity. So this is going to be going to both ways forever and ever. So we can call this all real numbers. Just as a recall, all real numbers is a shorthand symbol you use to write from negative infinity to positive infinity. And the range, this range here, this is pointing downward, so it's going to negative infinity since it has an arrow. And this side's going to positive infinity. So the range is also all real numbers. And that's it. A cubic function has two sides where it points to the left and right, and a square root has a one side. It either points right or left. All right, let's get into one more slide here before we get into the homework. So you guys, in the last slide here, we were looking at the original square root function and the original cube root function. But what if it has extra stuff to the side? Like sometimes you have x and it's being added to some number, or some number being added outside the root or subtracted outside the root. So let's talk about shifts. Just like how we've handled it in the past, anytime you see the x and there is a minus sign attached to it, that is saying you're going to be shifting right. So minus sign on the inside of the root means right. Positive means left. So we understand that x moves left or right, so any number attached to it either means it's going to be moving right or left, and you can tell by looking at the sign. So whenever this is a negative, it moves right. Whenever it's a positive, it moves left. Whereas outside tells you the vertical shift, and so in this case, this positive means up, negative means down. And then this box that's being dotted here, that's just like the root number that you would have. Sometimes this is a square root, and sometimes this is a cube root. It doesn't matter. This way of reading your function will work for either case. So I just made that like an empty box in case it's a square root or a cube root. Now this a here is a number, and it's a number that usually sits outside of the root, and it's not the square root or the cube root. It's not the small number that goes here. It's just your coefficient or constant that sits outside, and it's always like in front of your x. So this is your slope. So your slope, when you use this, you have to use it sparingly. When you are using a here, you always have to put it over 1. You always have to put the slope value over 1. So the 1 is always your run. And then the vertex here is always going to be like whatever your h value is and your k. But you don't really need to remember this part, just these technicalities like the shifts. And one last thing. Whenever you have a square root, it needs 2 coordinate points. Meaning when you graph, you should have 2 coordinate points before you can connect the dots to make a curve. With a cube root, it needs 3 points. Okay. All right, so I think we have enough information now. Let's get into some homework problems. So I'm going to now go to page 2 of the homework in the packet, and we're going to start with problem number 1. All right, so here I have problem number 1 from packet 10, and this is page 2. And I have to create the graph and figure out, the vertex, y-intercept, and domain and range. So the first thing I want to start off is like figuring out what type of root do we have. So this here is a square root. So if this is a square root, then that means that I'm going to be plotting at least 2 points. A square root has at least 2 points on the graph, and it's also a one-sided curve. So I'm already visualizing what I'm going to be drawing. So looking at it, I do need to figure out the shifts so I can figure out the vertex. So in this case, this is -2 on the inside. A -2 on the inside means right 2, and a +3 on the outside means up 3. So I'm going to go right 2 from the origin, up 3, which is right here. And this is the vertex. And so my vertex here is at 2, 3. And from there, I'm going to grab my my next point. So I need one more point so I can know if I curve up, if I curve that way, if I curve down, or the down right. So what I do is I grab the slope. So my slope here is a number in front of the square root. So technically, there's no number there. So by default, it's always a 1. So my slope here is 1 over 1. So from the vertex, I'm going to go up 1 over 1 plot. And then because my point is right here, I want to curve the vertex towards that point. So I'm going to be curving up towards the right. And there's my curve. So I have 2 points. This looks like my one-sided curve. And now let's figure out the domain. So domain talks about the x values that's the furthest to the left. So the furthest x value to the left is 2. So it goes from 2 to positive infinity. So this goes from 2 to positive infinity, parentheses, bracket on the 2. And then the lowest y value here, it looks like it's at positive 3 is the lowest y value. And then this is pointing upwards, so it's going to positive infinity. So this is 3 positive infinity. And then from here, I need to figure out the y-intercept. And generally, we would do this. We would plug 0 in for x, right? We would do this. Plug 0 into our function. And then work this out to figure out our y value so we can figure out the y-intercept. So if I work this out, here's the thing that I'll start to notice. The inside of the root is 0 minus 2, so that makes -2. Add that with a 3, but hold up. We just said earlier that if you have a negative under a even root or a square root, this does not exist. There are no real solution. So because there are no solution or no real solution, that means that the y-intercept doesn't exist. So I'm just going to put in NA. Or you could just put in none as no y-intercept. And if you look at the graph, this makes sense. Notice how this curve, when drawn, it doesn't even touch the y-axis, which is why you don't have one here when you were trying to, calculate it. All right, so let's try another square root problem. So this square root has a negative outside. I'll deal with that later, but let's look inside. This is a positive 3 on the inside, so this is shifting left 3, and there's a negative 1 outside, so this is down 1. So if I go left 3, that leads me right here. Down 1 is right here. So here is my vertex. And so from there, my vertex coordinate is -3, -1. And then I got to use my slope here to get more points because I need one more point. So take a look. This has a -1 outside. So that means my slope had to have been a -1. So if my slope is -1 over 1, because you always have to make the run 1, I have to use my vertex and go down 1, and this is a positive 1, so I have to go right 1. So down 1, right 1, plots it right there, and then I'm connecting the dots. So this one actually goes downwards. Since that point was below the vertex, I have to go connect the dots, and it looks like I'm going this way. So domain. So the furthest x value to the left of this curve is right here, which is x equals -3. So we're starting at -3 for the x, and it is pointing to the right, so we're heading to positive infinity for the x values. So remember bracket and then always a parentheses for infinity. Now for the range, this is where it gets tricky. Notice the highest point on this curve is actually right here, and the y value there is -1. So the y value is -1, and it's the highest point. So I need to write it on the left side of my interval. Then the lowest y values, notice how this goes down with an arrow. So it's going to keep going down, 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 or to -infinity. So it goes from -infinity to -1, and I'm going to put a bracket at -1 for the y value because, well, that is where the closed circle happens. And now for the y-intercept, I do see that this curve crosses the y-axis, but this time to just get some accuracy here, I'm going to have to solve it out and plug in 0. So if I plug in 0 in for this, it looks like this would be -0 plus 3 is 3 minus 1. So I'm going to calculate this using my calculator. In your calculator, you can hit second x squared and it gets you a square root button. Or just press the blue button and x squared and you'll get the square root button. So if you take the square root of 3, let's go figure out what that number is. I'm going to go grab my calculator here. And it says in my calculator this is negative because there's a negative outside, so I'm just carrying that down, 1.73. And then I'm going to subtract that with 1. So if these are both negatives and I subtract, this is going to be a negative 2.73 for my y value. So that's the y value that goes here, 2.73. That looks kind of squished. All right, so for the y-intercept here, I plugged in 0 for x, found my y, so that's just a traditional way of finding the y-intercept. And notice that my picture really shows like it could be that value, right? So this curve curves down, and it's really close to that -3, and this is really close, 2.75. 2.73 is very close to -3, at least I would think. All right, let's do one more problem together. Okay, so in this problem here, we have a cube root function. So cube root, we mentioned a moment ago in one of the slides, is that you need 3 points. 3 points to plot with a cube root. So first start off with figuring out your vertex, which is based off the shift. So this is -3 plus 3, so this is right 3 up 3 because this is a plus 3, so that means up 3. So if I go right 3, up 3, this is right here at, it looks like 3, 3 for the vertex, so 3, 3. And then from there, I need to grab maybe some more points. So then I usually use the slope, so I'm going to go to my slope here, and there's no number in front of this root, so technically it's just a 1. So if this slope is 1 over 1, I have to go up 1 on the vertex and over 1. And then it would be right here. And so I would have to curve on this way. And then the other one, if I want to grab the third point, is actually the opposite direction of the slope. So instead of going up 1 over 1, I have to go down 1 to the left 1 and then plot, and then I'll kind of snake it that way or curve it the left way. And so then we have our cube root function curve. It looks like that zigzag we formed before. Now for this domain and range, you might have remembered me saying this. A domain for a cube root is always all real numbers, and that's just because, like, look at this curve. This is pointing left and right with arrows, so it's going from negative infinity to positive infinity. And this side's also curving downwards. It's hard to tell, but this will eventually start to curve downwards. And this side's curving up, so this is going to negative infinity to positive infinity. In other words, it's all real numbers. And then the y-intercept, this one I'll just plug in 0 for my x and work this out. So this would be 3 square root of 0 minus 3 plus 3. Now, if I simplify the inside here, 0 minus negative 3 is negative 3. The cube root of a negative 3 is negative 1.44. Then I'm going to bring down the plus 3. So we can take a cube root of a negative number. So in that case, I already did this part in the calculator. So if you're wondering where I got negative 1.44, I used the calculator. You just hit the second button. Not the second button, math button, and then hit option 4 to get the cube root of any number. So if I add these two numbers together, I get positive 1.56 as my y value. So I'm going to put that in here as my y value. And if you look at the graph here, notice how this curve is between 2 and positive 1. So that definitely looks like a reasonable answer. All right, so hopefully that helps you with an idea of how to do the homework problem. So until next time, guys, see ya.